Hello YouTube and welcome to my channel. Recently in mailbag number 6 I displayed an order from the Electronic Goldmine. Inside that order there was 2 Fultron sensitive ultrasonic car alarm units. The item number is G24733. The price on them is about $13 US. The unit comes with a long cable terminated on a 1/8 inch stereo plug. The sensor is designed for a car, so therefore it runs off of 12 volts. The plug is wired up so the tip is positive, the middle is the output, and the base of the plug is negative. I was really excited to get this sensor to use it with my ESP8266 and tie it into my Home Assistant. Home Assistant is a package that I use to run my home automation system at home. I eagerly started testing this unit and was a little disappointed. Turns out that the center pin on the 1/8 inch or 3.5 millimeter plug is less than useful. With no motion, it comes out at 11.87 volts max. With motion, it drops down to 11.71. Initially, I thought it was a pulse that I was missing and my voltmeter was just seeing the difference. However, I was mistaken. So it sadly turns out that the output of this device is not going to be useful for my ESP8266 project. So I'm going to have to modify it. I find it interesting to reverse engineer equipment and modify it to your needs. This modification, or hack, will be no different. So let's fire up the soldering iron and get started. Today we're going to look at a Fultron sensor from the Electronic Goldmine. This is using an ultrasonic device for sending and receiving. It outputs a little light when it detects something. There's a sensitivity control. There's a cable that comes with it. The cable will power it up, and it also has a sensor line on it. The sensor, I believe, is in the center. And let's have a look inside.
4 screws, your Phillips head. I've found a new use for my magnet that I pulled out of a microwave that makes a really good spot to throw your screws when you're working on things. You don't have to worry about dropping them on the floor or losing them. Pretty easy to pull these out. Should get my wow stick out for this. What we're going to find in here, I've had one apart already, is a small circuit board with a 555 timer circuit on it. Okay, here we have the board.
See if we can pull this out. There's our circuit. Now the thing of interest, if you look at the Electronic Goldmine video, he's telling everybody to tie into the LED, which comes up and around and is tied into right there. That's okay. You can do that. You can certainly put a sonic alarm on that, but it doesn't sit well with me because the cable that's coming up is a 3-pin connection. Right here we have plus 12 volts. The red wire is the signal. So why not use the signal? The reason that he wasn't using the signal is that the voltage on that pin varies from 11.71 as a minimum when it detects something to 11.87 when it's a maximum or no movement noticed. So it's a little difficult to use a microcontroller for that analog voltage because you're only looking at about 1.6 or 0.16 volts DC. So what I found is the circuitry for that LED, which is in here. Let's see if we can move some of these wires out of the way. This 1K ohm resistor right here feeds the LED at the front panel. If we unsolder this pin and add a resistor of 220 ohms, 220 ohms, tie it together, and then what we can do is pull that output off. That will give us a 3.3 logic signal when that LED turns on. Here's the same unit that's been modified. Right here, what I've done is I've taken the 1K resistor up, lifted the one leg out, soldered in a 220 ohm resistor, joined them together. This junction point here will now be a logic level. It can be readable by Arduino or by ESP8266. I've just written a sketch for the Arduino. I have the Arduino set up on my workbench. Right here is pin 3, which is going over to our new logic output of the board. I've installed a little beeper from ground over to pin 11. So when the Arduino sees this pin go high, it will turn on the beeper. This device is very sensitive, so just moving it will cause it to trigger. At the same time, the LED will still function. You can see just by touching it, we're getting quite a signal. Okay, in case you have the same board and you're trying to modify it, the output pin is right here. It is a red wire right there. So we're going to remove the red wire. We're going to tie it to the junction of these two resistors that we've now soldered together. The 220 ohm resistor goes right in here. That's one side of the 1K ohm resistor. So we unsolder the one side of the 1K ohm resistor, install a 220, tie the 220 to the other side of the 1K, and at the junction, which is in free air, right here, we take that and bring it over to the output, which is the red wire. Here's the modification complete. We've got the two resistors. This is the 220 ohm resistor that was on the previous side of the 1K. I've joined the two together, had to put a small extension cable onto the red wire. I'm using some heat shrink to make sure that everything is safe. Once it goes back in the box, it'll be just like nothing happened. We'll have everything all working. I've temporarily put the 1/8 inch stereo plug into a jack, wired up the red to give us 12 volts, the yellow is the output, the black is the ground. I've brought the yellow around over to pin 3, so the output of this device is coming into the Arduino on pin 3, and the beeper is on pin 11. So when this device sees motion, it will alert it on pin 3. The Arduino will then turn on our sonar sensor. Here we go. This is just a demonstration to show you that it's working. What will actually happen is I'll be using an ESP8266, which will then send it over the MQTT network to my home assistant. At that point, the automation can do whatever we decide. I hope you found this video entertaining. If nothing else, it shows you that you can modify an existing product to suit your needs. Don't be afraid to open things up, don't be afraid to figure out how it works, and don't be afraid to modify it. Of course, you want to be safe, so follow all the rules and regulations for your jurisdiction. So thanks for watching. If you found it entertaining, please give me a thumbs up, add some comments if you have questions, and subscribe if you want to see more. Thank you.